Welcome to the online lecture for 3.1 over quadratic functions. So we've dealt with quadratic functions, those that make a parabola, and we've dealt with mainly just graphing them in a very simplified way. Y equals x squared was the parent graph, we shifted it around. Now we're going to be looking at quadratic functions more in depth. Quadratic functions can either be in standard form or in vertex form. And really you can get right from standard form down to vertex form by completing this square here. And we'll be doing that later on with some actual numbers. So we're going to start with vertex form. This is what I'm really more concerned about. So when a quadratic function's in vertex form, there's x minus h right here, or x plus h, it just really depends. This h and this k out here are what the vertex is. And the vertex, and I'll blow up these pictures in a second, but the vertex is either the minimum point or the maximum point, depending on if your parabola is opening up or if your parabola is, opening downwards. There's also something called the axis of symmetry, and that is a vertical line that passes through the vertex. If you notice in both standard form and vertex form, the a leads the way. So the a is the leading coefficient, and a determines really the entire parabola, essentially. If a is greater than 0, so if a is a positive value, the parabola is going to open up, and if a is less than 0, if it's a negative value, the parabola will open downwards. So if you take a look at this one right here, while we don't have an actual equation for this, it's an example, I just found it online. It's an example of a parabola opening upwards, and you can see a lot of the things we've talked about this year, such as the x-intercepts, here are -1 and 3. There's a maximum of 2 x-intercepts with every parabola. There's a y-intercept of -3, and with the parabolas we're dealing with, we're only going to have one y-intercept. There's the axis of symmetry, the vertical line that passes through the vertex. In this case, this vertical line would be x equals 1, since it's the vertical line passing through where x is 1. And the vertex down here is the minimum point of the parabola. The range of this parabola would be from -4 all the way up to infinity. So since our vertex is all the way down at the bottom, it's our minimum point. Let's take a look at this parabola here. This parabola actually has an equation, which is kind of neat, so I just found this online as well. If you notice, a is -1, there's that negative out there. So remember, a leads the way. A kind of decides what our parabola will look like, and since a is negative, it's sad, we're going to be frowning. We're opening down. Our vertex, therefore, is a maximum point. It's all the way at the top. Our axis of symmetry here is the line x equals 2. The really cool thing is if you notice where the vertex is, 2, 5, the x-coordinate's 2. And the axis of symmetry is going to have that same x-coordinate because it passes through the vertex. If you look at the equation, it's in vertex form. So you have x minus h. H is 2 plus 5. K is 5. So the vertex is at +2, +5. We're going to get into this more in depth. If you look over here at our objectives, during this lesson, or by the end of it, you should be able to, if you're given the equation of a parabola in either vertex form or standard form, again right here, you are going to be able to identify its direction. Is it opening up or opening down? Identify its vertex, its minimum point or maximum point. Determine the intercepts, both the x-intercepts and y-intercepts. You're going to be able to graph it using all of this information that you found in objectives 1 through 3. You're going to be able to determine the axis of symmetry, which is probably the simplest thing to do. Find the maximum or minimum value, which would be the vertex. And find the domain and the range, which we've already had extensive practice with, so that part shouldn't be that bad. And hint, the domain will always be all real numbers from -infinity to +infinity with the types of parabolas that we have. It's the range that's limited. So let's get started with our first example here, and it will be a quadratic in vertex form. Because this is an online lecture, you're able to obviously go back to any point that you need. So if you need to write any of this down, please do. I'd recommend writing down everything that's on the left here and maybe sketching some of these examples in your notes. I will also be providing an example problem and then one for you to do, so pause the video and do on your own. So this will be very similar to how we work in class when I'm walking around and checking your work. So really use this to get some practice. I also highly recommend doing the book problems as well. I'll provide a couple problems with solutions for you, but it's going to be really helpful to do some of the book work in order to get the hang of this. This section is a lot of work, so you got to put the work in order to get the output that you want. As you can see here, we have our first example, and in this case f of x equals 2 times the quantity x plus 3 squared minus 8. This is in vertex form. Since our a value is 2, the a leads the way, it's positive, that means our parabola will open up. Since it is in vertex form, we're able to easily find the vertex. And if you look at where the x is, it has a plus 3 in there. That means that the x-coordinate of our vertex is the opposite of that. It's negative 3. And the value at the very end, which is negative 8, gives us our actual y value of our vertex. So our vertex is at negative 3, negative 8. Now in order to find the x-intercepts, the next thing, we have to let y equal 0. So when we let y be 0, we end up getting 0 equals this whole thing, 2 times x minus 3, plus 3, quantity squared minus 8. And solving, let's make it a little easier to see, solving for x, we're going to add 8 to both sides, which gives us 8 equals 2 times the quantity x plus 3 squared. Dividing by 2 on both sides will give us 4 equals x plus 3 squared. Now from here, we're going to take the square root of both sides. And that gives us two solutions. When we take the square root of 4, remember we get positive 2 and negative 2. So we're going to have plus or minus 2 is going to equal x plus 3. Well, that means we're going to have two x-intercepts here. We're going to have to account for the fact that negative 2 equals x plus 3. And we're going to have to account for the fact that positive 2 equals x plus 3. And when we solve for each one of these by subtracting 3, we'll get negative 5 as one of our x-intercepts. Subtracting 3 over here will give us negative 1 as our second x-intercept. In order to, moving over to the right over here, in order to find our y-intercepts, that's when x is 0. So this is a little bit easier. And remember that f of x is just a fancy way to write y. So I'm going to replace f of x with y and say that y equals 2. And instead of writing x, remember we plug in x is 0. 0 plus 3 quantity squared minus 8. Well, what is 0 plus 3? That's just 3. So 3 squared is 9 minus 8. This is 18 minus 8. Our y-intercept is 10. Remember, we only have one y-intercept. The axis of symmetry, once it's graphed, it'll be a little bit easier to see the axis of symmetry. So some of you may choose to graph at this point. In fact, the problems in the book have you doing the direction, vertex, x and y intercepts, and then graphing it. From here, you really could graph. So let's actually go into the graph right now. All right, the first thing that we're going to look at is the vertex. It's kind of like home base of what we're doing. So at negative 3, negative 8, we're going to plot a point. Right down here. Sorry, I'm using my finger on an iPad, so it's not going to be perfect, but there we go, negative 3, negative 8. And then our x-intercepts are where we cross the x-axis, so we're going to be out at negative 5. 1, 2, 3, 4, 5. And then we're going to be at negative 1. And then our y-intercept is all the way up 10. Up here. So we can graph our parabola from this point. And it kind of curves this way. There we go. All right, that is what our parabola ends up looking like. Now, in order to find the axis of symmetry, we said that the axis of symmetry is a vertical line that passes through the vertex. And so our axis of symmetry is going to pass through this vertex here. And it's going to be this dashed line right here. Now, you don't actually have to graph it. I'm just showing you what it looks like. And that's why our axis of symmetry is x equals a number, because it's a vertical line. And in this case, since it passes through where x is -3, it is the line x equals -3. If you notice, this value right here for the axis of symmetry and the x-coordinate for the vertex are the same. That's because they go through the same point. All right, the next stuff is pretty simple once you've graphed it, so just like the axis of symmetry was. The minimum, in this case, it'll ask to find minimum or maximum. Well, there's no maximum of this graph because it goes all the way up to infinity. However, the minimum point is down at -8. It's down at -8 because our minimum point is our vertex, and we're going to use the y value of the vertex there, right here. The last two things are the domain and the range. The domain is our x values, and in this case, for our parabolas, our domain's always going to be all real numbers, -infinity to +infinity. And in this case, since our minimum value is -8, we can equal -8 and travel all the way up to infinity. I'm going to give you an example to try, and you will find all these things on your own. Okay, here is your example to try. You have f of x equals negative the quantity x minus 4 squared plus 1. Go ahead and find all of the things that we just found, and you can pause the video right now because in a few seconds you will see all of the solutions. Good luck. Here are the solutions to this parabola. As you can see, since the a value is -1 out in front, our direction is downwards. And that means our vertex of 4, 1, again, because it's a -4 in here, that means the x value is +4. The +1 is just a +1 for our vertex, which is right here. This vertex is actually a maximum value instead of a minimum. So a lot of times it'll ask what is the maximum or minimum value. And in this case, because we're going vertically, maximum, minimum, our maximum is just the y value of 1. In order to find the x-intercepts, which are 3 and 5, 3 and 5, we set y to 0, and then we solved for x. When we took the square root of 1, be careful, it's both +1 and -1, and therefore we have two x-intercepts, which are shown here and here. And then the y-intercept, we let x be 0. -4 quantity squared is 16. That negative out front makes it -16 plus 1 is a y-intercept of -15, which is shown down here on the graph. Our axis of symmetry is the vertical line x equals 4. It is running vertically through the vertex. The domain, again, is all real numbers, and the range, since we're opening downward, spans all the way from -infinity up through and including 1. We did two examples today of parabolas, or quadratic functions really, in vertex form. This is part of 3.1, and when you return on Tuesday, we will look at quadratic functions in standard form and completing the square in order to get them into vertex form. I highly suggest that you do some of the textbook examples here. The entire textbook assignment is page 328 to 329, 1 through 29 odd. But the first, 1 up through 15 are in vertex form, and the rest of them are in standard form. So if you just do 1 to 15 on, you'll really be in a good spot for us to rejoin class on Tuesday. Have a great rest of your weekend. See you guys on Tuesday. Bye-bye.